Alright guys, so just quickly I've knocked up a drawing for this balance arbor that we're going to make up for the hub and the wheel. Taper, the numbers worked out at 6.98 degrees, so it's a fair bit at 7 degrees, 14 degrees included angle. I'm going to cut an M14 thread on here, so when I do push the hub up, I can do a finger nut, just a milled finger nut that I can use to lock that taper up. I may not need it, it may sit up there and lock up quite comfortably itself, but I'll just put it in there for belts and braces. End shafts are diameter 12 on either side, they're going to be fairly accurate. And I'm going to put very light centers in the ends. Matter of fact, I just want the center tips just contacting on these to minimize the surface area, and will minimize that friction as well, because I do want to balance this between centers in the lathe. I haven't got a balancing jig with rollers or such like, so we'll give that a go. I think that it's going to be close enough for what we need to do. Stock wise, I've got this bit of rusted stock, and that's how I found it. I don't know what the material is. I'd prefer this to be 10-20.2% carbon steel, something light like that. I don't really want it to be a 4140 or an EN25 or any of the high tensiles. They tend to move quite a bit and go like bananas, and even after you've machined them, they will tend to move if they haven't been stress relieved. So we'll get a bit of an indication when we start machining this what this material is. Now I will be stress relieving this. As I said, when I finish machining this, we don't want this to move. We want it to stay dead straight for the rest of its life. So we are going to heat treat this in a different sort of a way to stress relieve it, and then we'll go ahead and do our final machining. So fairly straightforward. As far as the taper goes, I'm going to mount the hub up in the chuck, and I can use my little lever indicator just to zero that in, clock that in, and get that as close as we can as a start. But we will be bluing that as we go, just to check that taper as we machine it. I will be doing it between centers with a drive dog as well, so that I know that everything's dead true. And one of the jobs we'll have to do too, since I've moved the lathe, is I'm going to have to reset up the tailstock to get it running parallel as well. So a little bit to do on this, but we'll make a start and we'll get this on the go, and hopefully start getting that little taper grinder back together again soon. Alright guys, we'll get this cut off the length, and we'll see you back in the lathe. Alright guys, just as a quick addendum to this arbor that we're going to be making up, as you saw in the previous video when I was trying to get this hub off the taper, the nut is integral with the taper. So in other words, you're actually screwing that taper on and locking that. Very poor design, and trying to get that taper unlocked again, as you saw, we had to go through a fair bit of heartache to get that to move. So to me, very poor design. So we're going to redesign this and make up a new hub. And I wanted to make sure that that new hub was going to fit on this arbor to allow it to be balanced, and this is what we've come up with. So this is the new hub design. The difference is on this one here, it's a lot shorter in the nose, but I've got an internal thread up inside here and a jacking nut that will screw up inside that will hit on the face of that taper and actually jack that taper off, or that hub off the taper on the shaft. So I can use this design for both arrangements. Just with the new jacking arrangement on the hub, I'll have to put a spacer washer in here, that's all. So we can use that design. I'm going to go with the existing hub just for the time being. This will be a future project to get this made up. A couple of things, I've made the pin punch centers exactly the same, and the pin punch centers on here I've also made the same as the locking nut for the wheel as well. So we'll have common tools, if you like, right throughout the whole arrangement. So as I said, future project to do, be an interesting one to do actually, and get this issue sorted out. All right guys, well, we've got our stock all cut. Let's put that to one side for the time being. Let's focus on the arbor as well. I guess the other reason I'm going to need this arbor for as well, just before we do leave, is that I'm going to have to mount the new hub on the taper to do all the final machining on the OD. So I do need this first, so we'll get set up in the lathe, and we'll make a start. Right guys, so the plan for this is we're going to face both ends off the length. I'm going to do all the work initially in the 3-jaw chuck, so we'll machine one end first, flip it over, do the other end second. We'll roughly machine the taper, and we're going to leave it about 2 mil oversized total. What I'm going to do then is I'm going to go and stress relieve it, let it sit for quite a while, and then wrap it up in some fibre fracks, just let it cool down overnight. And then we'll come back between centres and we'll do all of our final machining. So at this stage, we're just going to start blocking it out and getting it roughly to shape. Tips around. I'll put the larger radius one up first, I think. Alright guys, we're going to machine this down to about 28 millimeters in diameter for about 120 millimeters in length, and then we'll machine down to about diameter 16 for around about 75 millimeters of length. That'll allow us to get that machine down, cut the M14, machine the 14 diameter register, and also machine out the 12 mil spigot at the end. Then we'll flip it over and then do the final machining at the back end and start to cut this taper in. Alright guys, let's get started. Oops. Righto, we've got it blocked out. What we'll do is we'll set the hub up in the 3-jaw. We'll get that clocked up with the indicator, little finger indicator, and we'll get that taper set. Righto guys, we've got that running pretty true now. So it's reading 0 there. You see how that moves around as we try and crank it, and that's running bang on 0 there. Alright, we'll get the blank into place, and we'll just get this taper roughly cut in. Alright guys, let's start cutting this taper in, and we'll see how our powered drive assembly goes, eh? That is absolutely brilliant. That's a beautiful finish on that. I've never ever been able to cut a taper and get a finish like that. The control you get over this little drill is absolutely fantastic. All right, we'll leave it at that. I'm going to throw that in the pot belly is what we're going to use for stress relieving. Obviously I can't control the temperature on this. Stress relieving, you'd usually bump it around about 630 to 650 degrees, and you'd let it soak for an hour per inch of thickness, and then let it cool down in the furnace once she's soaked out for that period of time. but we'll take it out and we'll wrap it up in some fibre fracks, some insulating wool. Alright, I might just sit the hub on this and just get a bit of a feel for it. It's miles oversized yet, so probably not going to get a good engagement, but we'll have a look and see how that looks anyway. Oh no, I'll just pop it in here. I've got it wrapped on some wire. I want to try and keep it staying vertically the whole time. Just get it up so it's down the side of the pot belly there. Alright, I might do this with both hands. We'll come back when she's done. Right, we've had this out of the pot belly now for, I guess, 4 or 5 hours. Alright, it's probably just less than 100 degrees now, so we'll let that air cool out now. It's probably went a little bit over temperature on this. It's, yeah, you haven't got control on the pot belly. Alright guys, so I've just given that a bit of a clean up with some emery. Got a little bit hot down that end there. It's, I was hoping it hadn't hardened up, but it's fine. Just a bit of scaling on there. Going to clean up the ends and then just gently or lightly just touch the centers just to get them cleaned up. We'll also face them off as well. And then we'll set it up between centers to do our machining. And I do my between centers set up a little bit differently, and I'll show you how I do that. Alright guys, I've had to revert to the setup. I have machined this at exactly 60 degrees and undercut back in here. I won't tell you how I did that because it was a bit dodgy. But needless to say, it is spot on. It's spot on center now. A quirky thing I found out with my lathe is in the back where the cam locks are that lock the chuck into place. When I put the faceplate on and did the cams up, the cam ends actually run into the space where the spindle is, and I can't get my number of Morse 5 taper to actually seat up inside the taper because the cam locks are just poking through a little bit, so I'll have to rectify that at some stage. Because I've never done turning between centers in that way, I've always done it this way. So once we machine this, it's dead true to the center line of the lathe. You can put centers in there and there may be a little bit of dirt or a bit of something in there that just kicks them off a little bit, but this is a way of getting it absolutely dead nut spot on, is to machine it while it's locked up in the jaws of the chuck. Alright, so that's our drive arrangement. Now the first thing I need to do is to check our tapered run out on this unit. I don't want to lock that up too tight because it will tend to concertina a little bit, so we want a little bit there, which is fine. We'll take a touch off here, and we'll see how that is. Right, so I've got a couple of lands on that. So let's bang on 16.9. That's 16.83. So I've got 0.07 millimeters taper in that. So I'm going to go and adjust my tailstock now. I won't take you through that laborious task, and we'll get this squared up and running parallel. Alright guys, I don't know whether I fluked this, but we've got this pretty much within the first adjustment. So I'll show you where we're at with that. So it's reading up at 70.005. Oh, and that's measuring just a tad over 70.005. So what we're doing here, we'll call that parallel. Alright, let's start getting some datum points sorted out, our end stops, and we'll start getting this knocked out. We're going to machine this down to 14 to start with, and then we'll knock it down to the 12. We've got a thread to cut on that. Then we'll flip it over down to the diameter 12 on the other side, then we'll flip it back and we'll do the taper. And we'll see now, before I get to this 14, I'm going to turn it over. So it's always a good idea to try and end for end it at least twice throughout the machining regime, just to even out the stresses as we go. So we'll just end for end it now. We're up by about 0.5 millimeter on that. Right, we've got about a millimetre to take off that. That's measuring 13. We've got to come down to 12. I'll just do a little cut on this taper because I do want to turn it around again, and we should be able to slip the hub over this diameter here and just see how things are looking. So that'll help it cool down. There's a little bit of heat in that. I don't want to really come to size with that sort of heat in it. Alright guys, I've made a slight change to the original design, and that was I've increased the length of that 14mm thread we're going to do. We're going to keep it at 18 TPI, which is common throughout this grinder. So that was the arrangement we had before to match up with the existing hub arrangement, which is that one there. But the new hub arrangement will have a shorter nose on it, so we can screw him up a little bit further to lock him up on the taper. Alright, I've taken the taper out, and I'll just do a scratch check on that now. So we'll put our marks in. Our marks in again. I have had a look at it. We will need to make some adjustments. It does fit over now, so we can check it out. So I'll give that a rub. And we can see that it's rubbing at the top end there. So I need to change that angle very slightly, only very slightly, to get that to match out. So we'll set this back up in the lathe. We'll get that taper sorted out, and we'll get that right before we finish our final machining and our thread cutting. Alright guys, we'll see you in a tick. Alright, so I've got my little lever indicator set up here, and I need to bring the top slide towards the camera. So I've just loosened it off a little bit. We're going to give it a very, very light tap, and we're only going to go a little bit to start with until we get a bit of a feel for it. We'll machine it, then we'll try the taper fit again. Right, so we've moved about 0.02 of a mil there. You get a bit of an idea how this is going to feel anyway. Alright guys, so that's our finished taper. I'm very happy with how that's come up. We're going to blue this up and then try it in the hub and see what the wipeout is like and what our contact is like. So I've got my tube of bearing blue. Now we don't need much of this at all. A couple of little dabs is all we need. Alright, very light. I'm going to pop this together, and I'm going to pop over to the vise, put that in the jaws, the soft jaws, and ring that together. I'm going to see what the transfer is like and what our contact area is like. So back in a tick, we'll see how that looks. Right, so that's our taper, male taper, and inside I can see, and it probably doesn't show up because the blue's not a good contrast on the shiny metal, but I've got a very, very light blue smear over the entire taper on this, so I'm very, very happy with how that's come up. Now 7 degrees is probably about, I guess, the maximum angle where you should get tapers to bite. So if I give that a little tap, yep, and that's bitten in there quite nicely. So I can't turn that. So very, very happy with how that's evolved. All right, let's go ahead and get these final ODs machined back, and then we'll cut our diameter 14 by 18 TPI thread for our lock nut that's going to go up against that face. All right, guys, we'll get this back in the lathe with the drive dog, and we'll finish this out. Hey guys, we're going to cut this 18 TPI left-hand thread. I'm going to do it as a left-hand thread. Not necessary, but everything else on this grinder is left-hand, so we'll follow that theme along. Depth of thread works at about 0.865 millimeters, so it's going to come just shy of this tail diameter here. We've got the undercut cut in. Battery did die when I was cutting that, so apologies for that. I would normally side cut just using the top slide, so I keep my top slide at 90 degrees and side cut off that. I don't come in at the 60-degree angle like a lot of guys do. I prefer to use my topside to side cut, but I've got it currently set at that 7 degrees, dialed in nicely. I want to keep it at that because I do want to make up that new hub with the jacking screw arrangement on it, and I don't want to change the topside around and have to go through the hassle of trying to reset that taper. So we'll see how we go. Just have to be very careful when we're doing our final cuts that we don't gall things up too much cutting on both sides of the flank. Alright, we'll get a scratch pass done first, and we'll make sure we've got our gearing set right and our levers set right, and we'll make a start. Alright, that's spot on. I have a metric lathe, and this is an imperial thread, so I'll need to keep the saddle engaged or the lead screw engaged the entire time. So we'll reverse back up into place, and then we'll continue our cut through. Alright, just cleaned up. Alright, I'll clean up the rest of this thread. Obviously I couldn't side cut to get the flanks quite nice, so I'll give that a bit of a clean up with some emery, and that'll be as good as new. Alright guys, so at the end of the day, that's this little arbor finished. And just got to make up the nut for it now, so we'll get set up to do that next. Alright guys, so that's how that thread's come up. It's come up very, very nice, so I'm very happy with how that balancing arbor's finished out. Alright, next thing we need to do is make up the nut. So I've got a bit of stock in here. I'll give it a quick pre-machine at the moment, and it is free cutting. Well, not free cutting, but it's soft stuff. It's certainly not a high tensile steel. When you go diameter 30 by around about 11 long, we'll do our diameter 13 by 18 TPI left-hand thread inside. Okay guys, we'll part this off. I'll set this back up in the 3-jaw so that I can bore it true, and then we'll cut the thread. I can start on the inside at the end and cut through with our thread without having to worry about a blind hole. So easy to part it off now and set it up and re-put it. Alright guys, we're going to get this machined out to about 12.4, ready to cut that left hand 18 TPI thread. I've set up my my soft jaws. I've got a separate chuck for soft jaws just to protect the OD surface of that, and also to set it up so that it's machining true. Alright guys, I've zeroed it out, so we'll get set up to cut this 18 TPI left hand thread. Just on another note, being able to make up your own tool holders, like I do with these multi-fix units, allows you to cut a much smaller slot to be able to fit these smaller tools in. The set that I came with, I think the minimum slot size was 16mm deep, which is quite big for these little tiny tools, and the other slot size I think is around about 28. So as I said, to be able to make up your own tools, cut the slots in there to suit your own particular small tools, makes life a lot easier. Right, let's make a start. I know that's all cut out very nicely. I won't bore you with watching this like grass grow. I'll get this knocked out and we'll come back when we're almost done and ready to start trialling it. Righto, so we've done our last cut on this. Okay, remember it's left hand thread. And that goes up beautifully. So, very happy how it's come up. Alright, the last thing I need to do on the nut is to drill a couple of holes for the pin wrench so that we can get this nipped up, and then we can try and do some balancing with it. Alright guys, we'll get this set up in the mill and we'll get the little holes done. Alright guys, quick little job I want to do this morning is to drill the holes in the nut for the pin wrench. And to do that I'm going to set up a 3-jaw chuck on the table of my milling machine. And if it's not critical, which this isn't, if it's a few thou out, it doesn't really matter. I put a dead center in the quill. I've got a machine bar with a center that's true to it. Drop that down, and with these clamps just loose and the table locked up, just give it a wiggle around, keep the tension on it, do the nuts up, and then you're within a few thou. If it's more critical, obviously it's great to get it within a bull's roar of what you want to do. Then you can set up your quill indicator around that to indicate around the bar stock and get it closer. But for what I'm doing today, this is ideal. Alright guys, let's get into it. Alright, all done. I've got to drill this through at a diameter 14 so that I can get that onto the arbor shaft. But I'll get this deburred, we'll get this drilled, and we'll try it on the arbor and we'll see how the balance of our wheel looks. Okay, it's just modifying this this pin wrench. As I mentioned previously, the diameter 14 hole that I need to put through these is going to impinge into these heads, so we just need to slot through and just open up the gap between the heads so that I can get that drill through. Alright, we didn't hit the heads on the way through, so we must be pretty central. Alright, I'll deburr all this and let's see how it all works out. Righto guys, let's see how everything fits together. Alright, well that works beautifully. Alright, the next thing I want to make up is a pin wrench for the locking nut on the grinding wheel itself. So that's the lock nut there for the grinding wheel. They're 50mm centers. I can't find any pin wrenches with those types of centers, so we're going to make one up. Alright guys, that's a bit of stock I'm going to make this 50 center pin wrench out of. It's a bit of 65mm wide, flat by 6mm thick. So I'm just going to drill a hole, diameter 35, so it clears all the threads as I put it onto the arbor, or onto the hub. We'll pop a couple of holes in there to do the 2 pins, and then I'm going to shape out a handle on the bandsaw for this. So I'll do this off camera. We've already seen making up a pin wrench already. We won't bore you with making up a second one. What I will do though is we'll set the hub up with a grinding wheel on my makeshift balancing rig. So let's see how that looks. Alright guys, so this is the rig that I've made up for balancing the wheel. I'm just using the table on the Bridgeport. I use the slot to actually drop the wheel into. Alright, I've previously marked the high spot there. Alright, we'll try that in another place. And we'll see if that comes to the top again. Alright, it's going to work out nicely. What I would do is set this up on the surface grinder. I would true the wheel up so that it's running concentric to the center line of the shaft, then take it down and then do the balancing on it. Alright guys, I think we'll wrap it up at that. As I said, I want to make up that other pin wrench for this, and we'll see how everything fits up into the grinder and see if we get a better finish, but we'll show that in another video. Alright guys, we'll see you soon.